Welcome. This video covers the common data object called a data frame. We're talking about the idea that we want to be able to read data that's not already in R into R. We need to know what kinds of objects we can store that data in. We've already looked at this vector. The vector is this one-dimensional thing that has everything in it of the same type. So all numbers, all character strings, that kind of thing. Well, a vector is not really useful for storing a full data set. When you think about a data set, most people think about having variables across the top. So you might have like 4 or 5 variables, and then you have different rows corresponding to the observations on those variables. And so really that's a two-dimensional structure, right? We got columns and we got rows. And so a data frame is going to be the perfect kind of object for storing this kind of idea of a data set. And that's what we're going to look at here. All right, when we think about a data frame, here's a little visual to help us out. We can see here that we have a two-dimensional object, right? There are rows and there are columns. So there's an ordering to the columns. So there's an ordering in one dimension and there's an ordering in a second dimension. So this is a two-dimensional object. And how we can sort of fit this in with what we were just talking about in the last video is that this first column is really just a vector. So a data frame is just a collection of vectors of the same length. And so how do we collect those vectors together? Well, those vectors correspond to our columns. So in this case, we have 3 vectors, each of the same length. They're each of length 4, and there are 3 of them. One has numeric data in it, one has character strings in it, and the other one has logical values in it. And so this is perfect for storing the kinds of data that you usually think about, right? We're going to have our variables going across the top. So maybe age, we might have weight, height, those kinds of things, school that they attend, something like that. So we have 4 variables there, and then we have observations on each one of those variables corresponding to the rows. And so you might think about how we would index and look at a two-dimensional object. With a one-dimensional object, we used square brackets and just gave it a single index. And that's because the number that we needed to give it there would just correspond to, in the one dimension, what value we wanted to return. Well, when we have a two-dimensional object, what we can think about is having that same kind of square bracket idea, but then having 2 spaces. So we have our first space corresponding to the rows, and then we put a comma followed by the second space, and here is where we would specify which column we want. So you can see here that the 1, 1 element of this data frame corresponds to 17. That is the first row, the first column. This 1, 2 element is the first row, second column. So we're going to have ways to access the different elements within our data frame using those square brackets. However, you might also see that I put this notation up here. There's this $sign idea. So a $sign is going to be a great way to get a single column back. And that's something that we commonly want to do. We want to just return one column and look at that thing. And so these columns, though, are just vectors. So when we return a single column, we're really just returning a vector, and then we can investigate that vector through the methods that we looked at last time. So there are some connections here to be made between data frames and vectors. Data frame is just a two-dimensional object where each one of the columns corresponds to a vector, and each one of those vectors need to be of the same length. All right, how do we create our own data frame? Well, just like we saw the C function to manually create a vector, we have this data.frame function to manually create a data frame. Here, what I need to have to populate a data frame would be 3 vectors, and in this case, 3 vectors of the exact same length. But again, the vectors don't need to be of the same type. So here's an X vector I'm creating using the C function that has these 6 values in it in quoted strings. So this is a character vector with the values A through F. I have a second value Y, second object Y I'm creating that has these numbers in it. A third object Z I'm creating that has these numbers in it. Each one of these things is of length 6, and so they can be put together in a data frame. What I need to do is just call data.frame, specify what I want the first column to be, second column, third column. And so, easy enough to create a data frame using this data.frame function. You can see the output of MyDF, so I've stored the results of this data frame call in MyDF, so I'm actually saving this as an R object. Now I can look at that thing by just typing MyDF into the console. Now, sometimes you have these R objects that are going to represent your columns, but you want to name them differently when you put them in the data set. So X, Y, and Z are not great data names necessarily, so maybe I want to say, oh, this first one's going to be called char because I know it's character data. So that's just a name I want to give it. The second one I'm going to call data1. Third one I'm going to call data2. And so you can do that whenever you create your data.frame, or when you call your data.frame function. You just specify what you want that name to be first with an equal sign, and then specify the object that has the data. Oops. And in this way, we're just going to specify different variable names. Now, like we looked at with that little visual, we can access the different elements of a data frame using square brackets. And what we need to do is separate the rows that we want by a comma from the columns that we want. So in this case, my DF looks like this. I can access just the second and fourth rows. If I leave an index blank, what that does is it returns all of that particular dimension. So in this case, we're going to return all of the columns in that call. So we get the second and fourth rows. We get all three of the columns. Over here, I get just the first column. So I'm specifying no rows. So it's going to say return all of the rows in the first column. So I just get back this guy. And you can see that this does not return a data frame, right? This is actually returning a vector. And so this is doing some simplification, which is not necessarily a great thing. We're going to look at tibbles later. Tibbles are a special data frame that will not simplify automatically. Here I'm saying from my data frame, grab the second row and all of the columns, and that returns, again, a nice looking data frame. Here I'm saying I want the second row, first column, and so this just gives me one element, this B right here. There are lots of other ways to access things within your data frame. One way is to use a character string to represent one of the columns and get that returned to you. So here what I'm doing, remember that this code right here, this is the C function creates a vector. And so I'm creating a vector that has two elements in it, char and data1. So there's a character vector with those two values in it. And so what that's going to do is it's going to try to match those to the column names that you have within the data set. And so I'm going to return all of my rows and columns corresponding to these two names that I have right here. Now, oftentimes you just want to return a single column. And so a very easy way to do that, the shorthand for doing that is the $sign operator. So if you type in my df and put a $sign, you can then put whatever variable name that you want, and it will return just that particular column. And what's really nice about using RStudio is that it's going to autofill for us. So for instance, if I go in and I start typing my df, I put a $sign and I just wait, it will then populate a bunch of choices. So it'll populate all of the possible column names from that data frame. And you can use your arrow keys to scroll up and down between them, and then just hit tab again when you find the one that you want to choose. And so it's just a nice way, especially if you have a data frame that has lots and lots of columns. You can just start typing the one that you want. As long as you know some of the letters, it's going to populate, and then you can choose it. So let's jump into R and play around with some data frames. All right, here we are in RStudio. We're going to continue that previous program we were working on. I'll just put a comment here that we're going to do some data frame practice. Let's go ahead and create our own data frame using that data.frame function. But first, we need some more data to play around with, right? So we have this myUnif object, which is a vector of length 100. We have our sorted value as well. So we have our sorted unif, another vector of length 100. And so what we could do is create some more data. Just like there's an runif function, let's go ahead and create a object called myNorm, which is 100 random let's actually do 50 random values from a standard normal distribution. Okay, so just like runif created random values from a uniform distribution, this is going to do from a normal distribution. So it's just going to be a bunch of random values. I'm going to specify that I want 50 of them. I'm also going to create a sorted version of this. So we'll do sorted norm, and in that object we're going to store the sorted values from myNorm. And so now we have four objects: myUnif, sorted unif, myNorm, and sorted norm. And I want to create a data frame. And this data frame is going to have two columns, one being the uniform and normal values, and then another one being the sorted uniform and sorted normal values stacked together. And then I'll have another column that represents whether the data is unsorted or sorted. So let's go ahead and start creating that. So we'll do data.frame. And so I want my first one to be the unsorted data. So I'll say unsorted equal. And then what I want to put here is my unif values and then my norm values. But I want them to be a vector, right? I need to specify the vector of values corresponding to the first column. Well, I can use the C function to combine together the my unif values and the my norm values. And so that's going to create a vector of length 150. Then I can create a sorted column. So I'm going to call this one sorted. And in that, I'm going to put together, again, these sorted values. Okay, so let's go ahead and run that code. And, well, we can't quite see it all over here. Let's just put head. So this head function is useful for just looking at the top part of a data set. And actually, I didn't say this is an R object, so I can't quite do that. So I'll go ahead, I'll hit the up arrow in my console, and it will give me the last line of code that I wrote. And I'll just wrap that function in what's called the head function. And so instead of getting the whole data set printed out, I just get the first 6 observations. All right, so this is good. I got unsorted values and sorted values, but I don't have any column representing whether they are uniform values or normal values. So let's go ahead and add a third column over here. And that third column is going to represent uniform or normal. And I'm going to use the rep function. So let's go ahead and just start with that. So I can do rep. So rep does replication, so it's going to repeat something a number of times. Let's look at the help for it. So rep replicates the values in X. Okay, well, what are the values in X? If you look here, X is a vector or a factor. So if I give rep a vector, I can tell it how many times I want it to repeat. So for instance, I could say rep, take in the value unif, because I'm going to have some uniform values, and I want you to repeat that 100 times. If I run that, I get a character vector that has unif repeated 100 times. And then if I do rep norm and put 50, because I have 50 of those, I can combine those together in a vector. Right? So I'll use C to combine together those. And now I have a vector of length 150, first 100 values unif, last 50 norm. So what I can do is I can just take that and put that as my third column. So I'm going to say dist for distribution and give it those values. I'm going to go ahead and drop this down a line just for good programming practices. And now when I run this, I get a data frame with those 3 columns. I'm going to go ahead and save that as an R object. So I'll call it my df. And now I have that object to look at. Okay. We can see it up here in the global environment. My df has 150 observations on 3 variables. Great. So maybe we want to access a couple of the elements of this thing. So let's just grab just the uniform values. And so those correspond to the first 100 values. So there are a couple ways I could do that. I could say my df, I want to grab 1 through 100 because those are the first 100 rows, and I want all of the columns. Okay, that returns exactly what I would expect over here, just the first 100 rows. Now, I might not need that third column because, well, I know that all these values are uniform, so I could do a -3 here. That's going to say everything except the third column. And now I'll just go back to first and second columns. If I wanted to get just the sorted values, I can type in my df, hit the $, and it populates all of the different columns that are on this data frame. And so I could just scroll down to sorted, hit tab again, and it gives me that, and then run that. So this will be just the sorted values. And so this is actually just returning a vector. It might look like this is a data frame, like it has 2 columns here, but it's really just one vector that's being returned that, just due to the spacing that I have in my console, it's returning it as it looks like that. So if I return it now with a little bit more space there, it's going to return it looking like 3 columns, but that's just because it can fit 3 things as it goes across. All right, so that wraps up our introduction to the data frame. This is really the most useful object for storing the kinds of data sets that we most commonly work with.